Let's start section 4.5 today. We're talking about proving triangles are congruent by side angle side and hypotenuse leg. Sounds fun, right? First of all, let's make sure we all understand what an included angle is. Consider a relationship involving two sides and the angle they form, their included angle. So we have side, side, and the included angle. Okay, it's the angle in between the two sides. Don't forget that, we need it. Postulate 20, the side angle side congruence postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. I'm going to hit pause for a second and write something in. So we have, if side RS is congruent to UV, and angle R is congruent to angle U, side RT is congruent to side UW. That's side angle side, and this is the included angle because it's in between the two sides. Then your triangles are congruent. Let's try a proof. So those are the two given things. We need to prove the triangles are congruent. And think about it. We're talking about side angle side right now, so let's find a side, an angle, and a side that will be congruent to each other. So here we have two parallel lines and a transversal. We can say that this angle is congruent to this angle because of the alternate interior angle theorem. So I'm going to say angle BCA is congruent to angle DAC because of alternate interior angle theorem. So I have a side and an angle, and now I need another side. I can say that those are congruent. Write that a little bit better, sorry. Those are congruent. So AC is congruent to AC. And that means AC is looking in the mirror and it's seeing itself. It's reflection or reflexive. Reflexive property of congruence. So now I have a side, an angle, and a side. I'm done. I can say triangle ABC is congruent to triangle CDA because of side angle side. Cool, not too bad. Example 2. Use the SAS and properties of shape. In the diagram, QS and RP pass through the center M of the circle. What can you conclude about MRS and MPQ? MRS and MPQ. So if it passes through the center of the circle, that means that all of these are congruent, and your angles are congruent too because they're vertical. So I have side angle side and side angle side. If you conclude that triangle MRS is congruent to triangle MPQ because of side angle side. Okay, you try this one. In the diagram, this is a square with 4 congruent sides and 4 right angles. R, S, T, and U are the midpoints of the sides. Also, RT is perpendicular to SU. And SU is congruent to VU. SU is congruent, that doesn't make sense. SU is congruent to TU. Hold on. That's an SV is congruent. And I can't erase it. SV, let's change it. SV is congruent to VU. SVVU. Those are congruent. Those are right. Prove that SVR is congruent to UVR. Okay, so it's a square with 4 congruent sides and 4 right angles. It says here that R, S, T, and U are the midpoints of the sides. So that means that all of these are congruent. SV is congruent to VU. We're proving that. I'm going to do this in blue so I know which triangles I'm looking at. SVR is congruent to UVR. Okay, I already have two sides are congruent and the angles are congruent. I just need to prove another side is congruent. So it looks like I have RV is congruent to RV because of the reflexive property. Now I have, let's do 3 tick marks there. Now I have side, angle, side. Okay, that seemed really complicated, but it wasn't. I marked up my drawing. I looked for a side and an angle, and then another side that that I could prove congruent. So we have side, angle, side. Okay, let's try another one. Prove that triangle BSR, that was messy, sorry. BSR and DUT. Okay, I'm going to mark what's congruent from the page before. All of those were congruent because those letters were the midpoint. Page back. It said that for right angles are ST and U. I'm sorry. It said that a square with 4 congruent sides and 4 right angles. And then we know that RST and U are the midpoints of the sides A, B, C, D. And then RT and SU are perpendicular, and SV and VU are congruent. SV and VU. But I already have a side angle side. This cut over with the problem, and I'm not sure what it is related to, so I'm going to scribble that out. And let's try. So, there is lots given. I'm not going to rewrite it on this page because it's all on a previous page, and I've marked it on my drawing. Okay? Now we can say that angle RBS and angle TDU are right because of the definition of perpendicular lines. Because they're both right, we can say they're congruent. That's a D. So we're going to say these are congruent. And that's the right angle congruence theorem. We know those sides are congruent because it was given. Actually, no. Let's say VS is congruent to UD and BR is congruent to TD. That should be a 4. Definition of midpoint. Let's just state the obvious. That's what we do with proofs. We'll make it 2 ticks there, UD, and 1 tick there. Okay, now we're done. We've proved side, angle, and side. So triangle BSR is congruent to triangle, let's see, we want BSR, so we're going to go DUT. Perfect. Because of side, angle, side. Alright, good job. In general, if you know the lengths of 2 sides and the measure of an angle that is not included between them, you can create 2 different triangles. So if I look at this, I have triangle ABC, and here I have triangle ABC. If you look at this side and this side, they're not congruent, but I have side-side angle and side-side, let's do this, sorry, side-side angle and side-side angle. Okay? Therefore, side-side angle is not a valid method for proving that triangles are congruent. Okay? It just isn't. To be honest, like, bad words are not used for proving proofs for geometry. So that's the way I always remembered it when I was younger. We weren't allowed to say them in our home. We weren't allowed to say them at all. They're not appropriate words. Not acceptable, so we don't use them in geometry either. Right triangles. In a right triangle, the sides adjacent to the right angle are called the legs. So this is my right angle, and the sides adjacent to it are called the legs. The side opposite the right angle is called the hypotenuse. So we have another theorem, theorem 4-5. The hypotenuse leg, that's how we're going to shorten it, congruence theorem. If the hypotenuse of the leg of the right triangle, if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the two triangles are congruent. So I have the hypotenuse and a leg, hypotenuse and a leg. So triangle ABC is congruent to triangle DEF. Given WY, which is the big one. It's always hard to mark the big ones. WY is congruent to XZ. WZ is perpendicular to ZY. And XY is perpendicular to ZY. Prove that those two are congruent. So we've written all the given. We know they're right triangles and the hypotenuses are congruent. We don't know one of the legs, so we need to state the other leg. We're looking for hypotenuse and a leg. So we're going to say ZY is congruent to ZY. It's reflexive. And now we can say triangle is congruent to triangle X because of hypotenuse leg. Those are pretty simple. Sign making. You are making a canvas sign to hang on the triangular wall over the door of the barn shown in the picture. You think you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS and PQ is congruent to PS. What postular theorem can you use to conclude that PQR is congruent to PSR? Well, we can't use hypotenuse legs. We don't know the length of the hypotenuse, but we do know those are congruent. RP is congruent to RP because it's reflexive. So the triangles are congruent because of side, angle, side. Yep, didn't need that sheet of paper. All right. Use the diagram at the right. Redraw angle ABC side by side with the corresponding parts in the same position. So this is B, it's a right triangle. This is C, it's a right triangle. AC, oops, A should be down here. AC is the hypotenuse. And then we look at BD, D is the short end, and we have the hypotenuse. So now we can see that the corresponding parts are in the same position. Use the diagram at the right. Use the information in the diagram to prove that ABC is congruent to BCD. So all of that is given. AC, we can say that angle ABC and angle BCD are right. Definition of perpendicular lines. And ABC is congruent to BCD because of the right angle congruence theorem. BC is congruent to BC. Reflexive. Oh, but that one doesn't matter, does it? We don't need that step. It's crossed out in blue. So we realize it's true, but we don't need it because we have hypotenuse leg. So triangle ACB congruent to, sorry about that, DBC because of hypotenuse leg. Sorry about that, Belle, but we got that one done. Daily homework quiz, page 1, page 2, 3, and 4. Good job.